Assalamualaikum warahmatullahi wabarakatuh, and a very good morning to Dr. Saripah and my fellow friends. In this video, me and my group members will discuss in details about ketone compound. We will discuss about the physical properties, spectroscopy, biological activities, and applications of ketone compound. Before that, let me introduce my group member, which are Nuruslina binti Abdul Razak, Nurin Jazlin binti Ahmad Azmi, me myself, Nur Ain Syafiqah binti Muhammad Syahrul Nizam, and Muhammad Adrian Alif Shah bin Muhammad Zulkifli. To start our discussion, let me explain a little bit about what is ketone and spectroscopy. Ketone is an organic compound characterized by the presence of a carbonyl group in which the carbon is covalently bonded to an oxygen atom as shown in the figure. And spectroscopy is a general term used for the instrumental processes by which information about molecular structure is obtained through careful analysis of the absorption, scattering, or emission of electromagnetic radiation by compounds. Firstly, let's learn about the physical properties of ketone. First, ketone is polar molecule because of the different electronegativity between carbon and oxygen, where carbon is the positive charge and oxygen hold the negative charge. Secondly, there is no hydrogen bonding between molecule even though it is polar because of the compound structure that cannot form the hydrogen bond between molecule. So therefore, the melting point and boiling point of ketone is in between non-polar compound and highly polar compound, which is between alkane, alkyl halide, and alcohol. What we can say here is that the melting point and boiling point of ketone is intermediate or moderate. Lastly, ketone is water insoluble except for 4 carbon or less, which means solubility falls with chain length. The solubility decreases as length of carbon increases. That's all for physical properties. Next, my friend will talk about spectroscopy of ketone.
Next, we're going to discuss about ketone spectroscopy. Organic compounds are often identified using spectroscopy. The process of testing compound using spectroscopy is very simple. The compounds are placed into the machine and the readout is printed. The difficult part comes in learning how to read the printout and determine what it is telling you. There are many ways to identify organic compounds using different spectrum, which are nuclear magnetic resonance, infrared, ultraviolet, and using mass spectroscopy. First, we're gonna look at is IR spectroscopy. In IR cases, we also need to look at the shape of the curves to determine what group is being represented. A ketone compound on an IR spectroscopy data will give result around 1750 to 1680 and have a small peak. In this picture, we can see the example of ketone in IR spectrum. Next is ultraviolet. UV spectroscopy is concerned with the study of absorption of UV radiation, which range around 200 to 400 nanometer. This absorption is characteristic and depends on the nature of the electron present. In ketone compounds, it contains double bond involving heteroatoms CO and double O. The transition will be n-pi, where an electron from non-bonding orbital is promoted to an anti-bonding pi orbital. This transition requires minimum energy and shows absorption band at longer wavelength around 300 nanometer. Then, going to NMR spectroscopy. NMR is the most powerful tool available for organic structure determination. It is used to study a wide variety of nuclei such as 1 hydrogen and 13 carbon. It's a spectroscopic technique to observe local magnetic fields around atomic nuclei. It refers to the energy of the absorption and the intensity of the signal that is proportional to the strength of the magnetic field. That means that hydrogen-1 MMR is the application in MMR spectroscopy with respect to hydrogen nuclei, while carbon-13 MMR is the application in MMR spectroscopy with respect to carbon within the molecules of the substance. For hydrogen-1 MMR, first we need to identify the chemical shift of ketone. We can see that ketone have chemical shift at 2.1 to 2.6 range. In this picture, we can see the example of ketone in hydrogen-1 MMR spectrum. For carbon-13 MMR, first we need to identify the chemical shift of the ketone. We can see that ketone have chemical shift at 205 to 220 range. A chemical shift at 205 to 22 range indicates that compound is ketone. In this picture, we can see example of ketone in 13 carbon NMR spectrum. Lastly, for mass spectroscopy, a mass spectrometer is an analytical technique that is used to measure the mass to charge ratio of ions. It is a tool that can measure a mass of a molecule only after it converts the molecule to gas phase ion by imparts an electrical charge to molecules and converts the resultant flux of electrically charged ions into an electrical current that is data system rates.
For the next part, which are biological activities of ketones. As we all know, ketone bodies, which also known as simple ketone, is produced by the liver during gluconeogenesis, which is a process that creates glucose in times of fasting and starvation. There are three ketone bodies produced by the liver, which are acetoacetate, beta-hydroxybutyrate, and acetone. These ketone bodies are used peripherally as an energy source when glucose is not readily available. So, the first biological activities of ketone is in diabetes. Diabetes is a condition in which the body cannot or will not produce insulin, which is an important molecule in glucose cycle. The lack of glucose will trigger the liver to begin making it. Without glucose in the cells, the body begins to uptake fatty acids from the blood in order to provide energy. As this happens in regular person, ketone bodies will release to be used for energy, but only if the proper intermediaries are present. This usually comes from the breakdown of glucose. In a diabetic, very little glucose has been broken down. This means that even the ketone bodies cannot be used for energy, so they begin to build up relatively quick. Upon this case, it causes sudden and severe ketoacidosis, which is a serious complication of diabetes that occurs when your body produces high levels of ketones. A dose of insulin will allow the blood glucose levels to drop, the intermediates required will be created from the breakdown of glucose, and the ketone bodies will be cleared out of the system. The second biological activities is in dieting and starvation. This kind of diet is usually focused on low carbohydrates and high protein. Since carbohydrates are complex forms of glucose, removing them from the diet effectively removes glucose. Without blood glucose, the cells in the body are again required to survive off fatty acids that derives from stored triglycerides. The liver undergo gluconeogenesis to produce glucose for the brain and also produce ketone for bodies. As the glucose levels get lower and lower, so do the intermediates required to utilize ketone bodies as energy. More ketone bodies will be made than can be used. They also start to build up, then will be removed by the kidneys. The complete lack of carbohydrates in this diet makes it incredibly hard for the body to keep up, so acidosis begins to occur. Much like in someone with diabetes, the level of acetone in the urine will increase and the breath may smell sweet or like acetone.
Next is the application of the ketones. The application of ketones are, first, the most common ketone is acetone, which is an excellent solvent for a number of plastics and synthetic fibers. Second, in the household, acetone is used as a nail paint remover and paint thinner. Third, in medicine, it is used in chemical peeling and for acne treatment. Methyl ethyl ketone (MEK), chemically butanol, is a common solvent. It is used in the production of textiles, varnishes, plastic, paint remover, paraffin, wax, and more. MEK is also used as a welding agent for plastics due to its dissolving properties. Lastly, cyclohexanone is another important ketone which is primarily used in the production of nylon. That's all from us. Thank you for watching. Bye!